Welcome to our section introducing Red Hat Ansible automation. In this section, we're going to talk about what Ansible is, what its common use cases are, and why it's right for you in your environment. Ansible itself is used for several facets of automating the systems you work with and the deployment of applications and infrastructure therein. The concept of infrastructure as code is a ubiquitous term in our industry today, and Ansible fits squarely inside that realm, where you can describe the environments you want to work with, and that could be from the infrastructure layer all the way to the applications you deploy within that environment for your particular use case. Ansible makes it a simple language to be able to describe that environment, to be able to save that work, and then to reuse it as often as you need to. When you describe infrastructure as code, it means that you have an easily reproducible environment that your workloads will live within. With Ansible, we're going to be able to describe that using a very simple language structure, as we'll flesh out throughout this course. We'll save it using very common industry tools, and we'll deploy it using a simple web user interface to make it very easy to manage for even the most juvenile system administrator. Because the language used with Ansible is so easy to author, it also means that those who aren't natively working and authoring code can both create and share these bits of code, as well as audit them for their viability. You don't have to have a master's degree in a language to be able to understand what is being described by Ansible when you write these workloads. Additionally, we want to adopt the concept of CI/CD, or continuous integration and continuous delivery practices. This means that we can write our first workload with Ansible, and as we continue to expand our environment or further develop our applications, we can then go back and iterate upon that code base, run it again, and enhance our environment without having to redo that initial work. So our baseline workload is ever expanding, but always enhancing the environments we're deploying within. Once you start deploying infrastructure as code, you're also getting a lot of benefits. One of the first ones is that you're going to remove the ability for humans to introduce errors. Once you've authored code, tested it, and are running it in production, you can reuse that code to reinstantiate the environment, redeploy your application, or whatever the case may be, without introducing human error. Human error is certainly a leading cause to troubleshooting times as well as delays on deployments. So being able to trust that the code will reinstantiate your environments means that you can do more meaningful work with your human time and less introduction of issues from human hands. So what is Ansible itself? Well, it's an open source platform and automation language. It's been around for quite some time and has quickly skyrocketed to the top choice for those trying to find automation tools and adopt DevOps style practices. It aims to be a few things, and the first one is simple. The language it chooses to use is very rudimentary to be able to author, yet very powerful. Its extensibility, meaning the amount of modules available to it to do workloads, is vast. So most of the work that system administrators do today already has modules created within Ansible to be able to do those workloads with an automated approach. Additionally, since it is extensible, you can leverage the vast library that already exists, as well as author your own if you so chose. Another benefit to Ansible and a design approach from its inception is that it wanted to be agentless, meaning there's no artifacts of using Ansible left on your targeted machines. There's no running agent that has to stay using system resources, both disk and CPU or memory, to be able to phone home to the mothership. Ansible doesn't require that. Ansible will connect to your remote systems in the same fashion as you do, meaning it'll use RDP in the case of Windows or SSH in the case of Linux if you have a blended environment, the native way that your system administrators are contacting those machines, and then perform its workload, leaving no artifact behind. That's huge because that means a few things. It means, first off, it's not taking those system resources. But that means it's also not introducing any vulnerabilities. It's not opening additional ports. It's not keeping connections live or constantly phoning out or waiting to be contacted. So there's a level of security that's benefited from that approach as well. I mentioned a blended environment, and Ansible does a really solid job of making sure that if you have a mixed environment of operating systems, or a mixed deployment of data centers, or a blend of cloud versus on-prem infrastructure, it can handle these all in one set of infrastructure as code playbooks, as we'll author in Ansible. I mentioned that it's simple, meaning that it's easy to author, easy to read, easy to audit. And that is huge, meaning that you don't have to spend a lot of time trying to decipher a difficult syntax to author this work, or to read through it and understand what its ambitions are or intentions are step by step. It's quite explicit and easy to read through. Marries natively with the version control systems used throughout the world today. Believe industry standard seems to be drifting into the world of Git and Git-based repositories, and Ansible natively lives in that ecosystem. When you are managing systems, the concept of inventories is what Ansible uses to collect them into a list of machines you have in your environment, and then those systems can then be grouped in any number of ways that makes sense to your management of those systems. Lastly, from developer to end user and even third-party partners that may be in your environment, Ansible allows you to express a DevOps style workflow. A developer can create the work, system administrators can leverage the work, managers can audit for intent and ambitions to make sure that it is on point for what the goals your team are trying to achieve, and sharing that work with third-party partners means it's easy to come up to speed and even contribute from their angle or just leverage your work directly. The philosophy behind Ansible that led to this product is that, the complexity of some of the tools that existed in the world prior to Ansible really slowed down productivity. It meant that developers had to learn an entire new tool as well as potentially a custom language for that tool, expressed with any number of elaborate syntax. Ansible definitely tries to kill that approach. The readability of Ansible workloads means that from developer to manager, everyone can stay in sync with the ambitions of the work and team, as well as the output from the code that gets authored. Ansible calls itself a desired state engine, meaning it puts an onus on the author to write code in a way to describe the end state, the desired state of the systems that are being managed. This is very nice considering that with the concept of idempotency, if a system is already in that state, Ansible will perform no work but just validate that. And if a system is not yet in that state, Ansible will leverage its bundled modules to make sure and perform the work necessary to take that machine or system into the described state. Here's an example in this illustration to show a set of steps that you would typically go through as a system administrator. And from an Ansible perspective, the real burden and only burden you have is to understand how to take your workloads through from start to finish in a precise order. Taking a look here, if you wanted to deploy your application, for example, you would first want to take a system and stop its monitoring. Once monitoring was turned off, so we suppress alerts, we would want to remove that system from a load balancer, taking it out of rotation so it doesn't receive traffic. Once it's out of there, we would stop the running services so that we could perform some work, deploy our application to get it into that latest version or whatnot that we may be deploying. And then lastly, we'd just reverse that. Starting back the services, adding it back to the load balancer, and then resuming monitoring. Now, because we author these steps with Ansible, we now have a reproducible set of steps, and we can move to the next 10 servers or 100 servers and reuse that same work. No longer do we have to log into each system and do this uniquely for each system. If that were done with human hands, we could see the number of issues and errors that could occur. But by authoring this with Ansible, we can reuse that workload, eliminate human errors, and scale this to not just 1 or 10, but thousands of servers where this could be done in an automated fashion. Ansible deployments, when it comes to the environment that will run Ansible itself, where you'll do your work, has the concept of control nodes and managed hosts. A control node is where Ansible is installed and you'll execute Ansible workloads from. This control node typically needs to be Linux. In our course today, we'll have already bootstrapped that control node with the tools you need so that you can begin working with Ansible to understand and explore how Ansible can solve your issues. And then there's the managed hosts. These are all the systems and ecosystem that you wish to control with the Ansible work you author. In our class, we'll use a variety of Windows-based machines that we'll control with Ansible workloads from our control node. The managed host will be collected into an inventory. You can have one or more inventories, depending on your environment, that describe the machines you have and any sort of uniqueness you wish to describe about them to Ansible. Perhaps you're running services on non-standard ports for connection. That's something you'll need to explicitly tell Ansible so that it knows how to contact your machines. But inventory can be created once and reused forever. Ansible uses the term plays. A play for Ansible is the set of steps that you wish to perform on these targeted hosts, these managed hosts that you've collected in inventory. Each of these steps is known as a task, and the list of tasks each call a module from the library of Ansible modules to perform their work. There's modules for any number of tasks we do routinely, managing users, installing typical software, whatever the case may be, managing a firewall. Ansible has a vast library of modules at your fingertips for you to leverage to perform the daily work that you would do. Additionally, in more advanced deployments, you can author these modules yourself. By default, Ansible authors its modules in Python in the Linux-based world and PowerShell, or typical languages that these systems would interpret, so that you can rely on the work that's done with Ansible being done in system-native languages. These aren't bits of code you'll ever have to descend into from an Ansible mindset, but are able to somewhat take for granted and just perform the work you need to do with a simple expression in Ansible plays. I mentioned previously the concept of idempotency. Ansible modules are intended to be idempotent, meaning that they will always validate the desired end state of your task and assess the machine for any work that need be done. If the machine is already in that desired state, it will perform no work. If it is not, it will attempt to perform whatever is necessary to remediate it to that state. And if it's unable to, it will always notify you of that issue, that it wasn't able to complete that, or that the system maybe wasn't able to be contacted, couldn't connect to that machine. And it'll always have a really good output to help describe what was done, what was found, and what was not able to be done, so that you can continue to look into that and maybe troubleshoot in those rare instances especially while you're getting started with Ansible. In the next image, you can see the typical Ansible deployment layout. You could have some back-end configuration management database, as well as public and private clouds or your data center. A user would author Ansible, which is what you'll be in this course. You'll go ahead and write that and save it typically into some sort of version control. In our course, we'll use an instance of GitLab to do so. And we'll author these Ansible playbooks. The Ansible playbooks will get stored into that version control system. And then you can see here, the playbooks will contain tasks written from the various modules that we just discussed. It will target systems that are from our inventories, which we'll create. And then we have a set of plugins or APIs that can be leveraged to perform the various Ansible work. And then once we've authored and saved that, you'll fire those plays. You'll execute them through the Ansible interface against those hosts, and you can see that your deployed hosts that you'll manage with Ansible, as well as the networking layer, can all be managed through this nice automated approach. When it comes time to use Ansible, to actually use these workloads, Red Hat Ansible Tower is available and we'll use throughout this course. Red Hat Ansible Tower is the web-based user interface provided by Ansible and will allow a nice, clean, full-featured web UI for you to perform all the work we need to do with Ansible, as you'll see throughout this course. It's built atop a RESTful API so that you can leverage under the hood all the features that are exposed from Ansible within a very clean interface. Just taking a look at some of the use cases that Ansible has for you. Configuration management. This is absolutely vital to the world of today, where you centralize the configuration descriptions of all of your deployed environments, applications, users, and so on and so forth in a single place so that it's described in code and can be reused whenever you need to. Same with application deployment. There's always a set of steps you must go through to get your application alive and running in your environment. Describing those steps to Ansible once allows you to do application deployment in an automated fashion going forward. When you need to create or alter infrastructure, provisioning is a real common go-to use case for Ansible so that you can create your cloud-based VMs or bootstrap an OS within your data center to your liking so that it can then proceed into application deployment and configuration. I mentioned the concept of continuous delivery, being able to iterate upon your work and enhance your work and then continue to deploy it over time means that you're spending your human time enhancing your environment as opposed to the same mundane tasks. This is key to a DevOps methodology, that you're working on next features, next fixes, as opposed to continually repeating the same mundane administrative tasks. Because this is all stored in a centralized location and is reusable, auditable code, you can then enhance security and compliance through Ansible. If you have a standard set of firewall settings, for example, that you want on all of your machines, you can have your networking team describe those to you, author them into Ansible, and ensure they're applied every time a system comes to life, and run that routinely to ensure that they're being enforced at all times. And lastly, orchestration listed here. Not only do you need to define the configuration, but how all of the pieces of your environment interact. Where do web nodes live? What does a database server look like? How do these two talk? On what ports? With what users and all of that? The orchestration of how these pieces of your puzzle connect is easily described in code for Ansible and then instantiated each time you execute your plays. Take a look at the quiz we have at the end of this section, and I'll see you in the next video.